Now this is the solution for the long exam set A. As the problem reads, you have a 10 kilogram marble ball slides to the left with a velocity of 0.40 or 0.400 meters per second. So that is my ball A, or my mass A in this case. So I will label that with A. Now, probably the tip that I would give you is whichever object is written first, you label it as A. Okay, according to the problem, it slides towards the left. So I'm going to sketch a broken arrow directed towards the left with a velocity of 0.400 meters per second. So I will denote that as my VA initial to be negative 0.400 meters per second. And I would like to emphasize we put negative because it's going to the left. And it's just a matter of convention. So if it's going to the right, then that would be positive. Okay, going back again, a 10-gram marble slides to the left with a velocity of magnitude 0.400 meters per second on the frictionless horizontal surface on an icy New York sideway and has a head-on elastic. So I'm hoping you notice this on the problem. It is an elastic collision with a larger 30 grams marble sliding to the right. So I will have here another marble. This is slightly larger. I will call that marble B, and that is moving to the right. I'm going to sketch an arrow. It should be slightly smaller arrow, sorry. Okay, that one, and it's moving towards the left, towards the right at a velocity as stated in the problem 0.200. So that's VB initial, and that would be positive 0.200 meters per second. Positive because whenever I have direction going to the right, meaning going to the right direction would be positive, and moving to the leftward direction will bear a negative sign. So that's my convention. Now I'm just going to write over here so that it will not be interchanged, that the mass of marble A is the smaller one, that is the 10 grams, and then the mass of marble B is the heavier one, which is just 30 grams. Alright, so in identifying, as I've said in class, we have to identify what the type of collision is, and it's very apparent and it's very clear also in this case that the collision is elastic because that is stated in the problem itself. The second one is, if that is the type of collision, you ask yourself what are the conserved quantities, because this will tell you of the equations that you can set up or use for this specific problem. Now the conserved quantities in this case is momentum, because this is always conserved regardless of collision, either elastic or inelastic, as well as another conserved quantity is kinetic energy in this case, because the collision is elastic. Now from there, this is telling us that we could create actually two equations out of this one because we have two conserved quantities. Now we start first with the conservation of momentum. So from the conservation of momentum, I could create an equation that will help me solve this problem of momentum. By the way, just to be clear, the problem asked us to find the velocity of each marble after the collision. So that means to say, after this collision, where does marble A and marble B went? So that is what we are looking for, and how fast they are moving. So from the conservation of conservation of momentum, we could have an equation of the momentum before the collision is just equal to the sum of the total momentum after the collision. So from there, momentum before collision involves the collision of two bodies. So that means that the momentum of A and the momentum of ball B initially, and that could just be equal to the momentum of A after collision, so A final, and the momentum of B also after collision, so I denoted it as B final. Alright, So we also already knew the equation of momentum, and that is just mv. So I'm just going to break this down into its equation. Ma vai, so this is for pai, plus mb massa b vbi. So you have to be very careful in terms of the notation so that it will not interchange. Now for paf, or momentum of a final, that is just mass of a, velocity of a final, plus for PBF, that is just mass of B, M sub B, VBF. So the final velocity of B. Now, if you try to inspect this one, MA is something that you know. MVAI also is given in the problem. So is MB, VBI also. MA, as I've said, is given. And notice that VAF is something that we have to find. So it's an unknown. MB is also a given. However, VBF is an unknown also. Now you notice that you have two unknowns. So that means to say that if this is your equation 1, you need another equation, because in algebra, as I keep on saying, if you have two equations, you need at least, if you have two unknowns, you need to have at least two equations also. We need at least two equations. So we only have one equation, so we need another equation, and we will be utilizing the kinetic energy. Now, in our discussion, I said that in order to spare yourself from the long derivation of the conservation of kinetic energy equation, we are just going to use this one. The velocity of A, and I want you to take special attention, before and after collision is just equal to the velocity of the other ball, both before and after collision. So that's why the equation looks slightly different from the conservation of momentum form. So this will look like this: VAI plus VAF is just equal to VBI plus VBF. So where your before in this case actually is being replaced by initial, and after is just replaced by final. Now I want you to take special attention when I said it's not really the same in form with the conservation of momentum, because as you can see here, this is VEI plus VBI. Now in our next equation, it's actually VAI plus VAF. So it's not, if you are thinking of patterns, it's slightly deviating or different from the conservation of momentum over here. Alright, so I'm just going to make that clear again and again, because most of you got it wrong in that case. Now, if you notice over here, what I'm going to do is I'm going to transpose VBI. So what will happen is this, it will look like this: VAI plus VAF minus VBI is just equal to VBF. So this one over here is my equation 2. So I now satisfied the algebraic condition that if I have two unknowns, at least I must have two equations. So I now have two equations. So what I'm going to do is, this is just a review of all of your algebra class. You are going to substitute equation 2 into equation 1 into 1. So I'm just going to copy this one, or maybe just rewrite that. So I have MA VAI plus mass of B VBI, and be very careful with the notations and subscripts. MA VAF plus MB MB VBF. So this VVF term here is where I will substitute my equation 2. So when I will do that, this will look like this. Just going to copy that one. You're going to utilize the technology. So that VBF is something that we will replace with VAI plus VAF. Be careful with the notation and the sign, minus VBI. So what you're going to do is that you're just going to distribute MB to each of the terms here. So that's that. So let's perform that one. What will happen to our equation is we have MA VAI plus the mass of B, mass of B VBI is equal to MA, that is VAF, plus MB VBI plus MB VAF, and then that will be minus M sub B VBI. Alright, so I'm just going to change the view to seamless. So from here, you now have this equation, so I'm just going to copy this one, and let's proceed to the other page. Copy and paste. Now if you try to inspect this one, the same as we did before, MA is given, VAI is given, MB is also given, VBI is given, MA is given, VAF is unknown, you don't know this one, MB is given, VBI is given, MB is given, VAF is an unknown, but notice that they are the same unknown. MB is given, VBI is also given. So this is very promising. It's because we are now dealing with an equation with one unknown, and surely we can solve one equation with one unknown without the need of other equation. So what you're going to do is to transpose everything that does not contain VAF to the left side of the equation. So I have MA VAI plus MB VBI minus MB VBI minus plus that's MB VBI, MB VBI. Alright, so I'm just going to initially check. I think I made some mistake over here. It should be MBVAI, not VBI. So I'm hoping you noticed it earlier. VAI, this should be VAI, VAF, VBI. Okay, so that means to say that the term over here is supposed to be VAI. Just gonna check this. Okay, so when you do that, that means to say this term also is VAI. This should be VAI. Okay, minus plus V. Okay, VBI. So what is left on the right hand side is MA VAF plus MB VA sub F. Now what you're going to do is, we don't really need or want an equation that is too somehow crowded. So what we're going to utilize is factoring, and you want to group together all the VAI. So I'm going to use a different color. So if you notice here, this has a term of VAI, this one also has a term of VAI, and this one I'm going to use maybe this one VBI also, and this one is VBI. So on that basis, I'm going to factor out common terms. So I'll start with VAI. So I have VAI. For the first term, this one over here, I have, what is left is MA. For the second term is I have minus MB. So I'm just factoring out. For the second term, that is VB sub I. First kine, this term, I have M sub B. And this one also here is M sub B. And on the other side, I can factor out VAF, which is an unknown. And then what is left is MA times or plus MB. So clearly, we can easily manipulate this by dividing both sides of the equation by MA plus MB. So I have M sub A plus M sub B. And you need to do that also on the left hand side of the equation to preserve the equality. And then you cancel that out. So you now have an expression for VAF. and that is a very good thing because we are looking for VAF. Alright, so you have VAF, and VAF is just this expression over here. Just going to copy that one, and that is your VAF. So from now, it's just a matter of substitution. I'm just going to rewrite VAF here and copy, or maybe paste that. So that's just the term above, and then we're going to do substitution. Now VAI is the velocity of your mass A. It's going towards the left at negative 0.400. You need to be meticulous of the sign, so it will be negative 0.400 meters per second. Mass of A is the smaller one, 10 grams. Mass B is the larger one, 30 grams. Plus the velocity of VBI, if you go back to the problem, is going towards the right, so that's positive 0.200. So plus 0.200 meters per second, mass of B plus mass of B, that is just 2 MB. So that's twice of mass of B. Mass of B is 30 grams. Everything is divided by the sum of the masses. You have 10 grams for A plus 30 grams for B. So when you do that, calculating that on your calculator, that will give you a value of positive 0.5 meters per second. So this is your VAF. That means to say, if you go back to the problem, after collision, your VAF tends to have a positive value, so it tends to move towards the right at a slightly larger velocity than before. So it moves now at 0.5 meters per second. Now you ask yourself, is this sensible? Of course that is sensible, because this one over here, the mass B, is larger than mass A. So you expect after the collision that A tends to move on the opposite direction, right? So that's how you should solve problems. Think if that is sensible. So let's proceed to the part where we look for the we're looking for VBF, but VBF now, once we are able to solve for VAF, is quite easy because we're just going to substitute our values from here. So I'm just going to write something like solving for VBF. So we already have that in place. That is just equation 2. So when you try to substitute the value, VAI again is negative 0.400 meters per second. VAF is 0.5. So it's very crucial that you got the correct answer in VAF over here, because once that is wrong, your VBF value will be affected as well. So you need to be very careful in your calculation. VBI minus VBI is 0.2, that is towards the right, so that's positive, and this is the value of your VB sub F. So when you do the calculation, that will give you a negative value, negative 0.1 meters per second. So this is your VBF. Alright, so the next thing, as I've said, and I keep on saying on class, is that whenever you get a value in a physics problem, you try to ask yourself if this is sensible. So going back to the problem, this is telling us that VBF after the collision tends to move towards the left. So let's try to look at the problem. VBF, that is the velocity of the larger mass, after the collision, based from our answer, tends towards to move after the collision towards the left with a slightly smaller velocity. So this is expected also. But then again, this is sensible because the most of the momentum is actually transferred towards the smaller mass, because it tends to move now at 0.5, initially 0.4, and now it's moving at 0.5. So we expect that the VBI also will tend to move at a smaller velocity to conserve the momentum. Alright, so this is the solution for long quiz set A.